This is the Uptick Newswire Stock Day podcast, sponsored by InvestorsHangout.com. Subscribe to us on iTunes, Google Play, and YouTube to stay up to date on penny stock news and interviews, public information on OTC, pink sheets, and microcap stocks from around the world, with your host, Everett Jolly.
On today's show, we have a brand new company and a brand new guest. And I've been watching this company now for the last 3 or 4 months. And I've asked them to come on to see what the real skinny is on their products, the Print Right 3D. We're talking no other than Sigma Labs, Inc. Well, they trade on the NASDAQ now, ticker symbol SGLB. And with us today is the CEO of that company, John Rice. John, welcome to the show.
Well, thank you. It's a great pleasure to be here.
You know, give my listeners a little bit about statement of who you guys are and what you guys do out there.
Sigma is a technology company. It's about 7 years old. It went from roots in Los Alamos National Laboratories to develop several products in the metallurgical field, and it has focused on developing in-process quality monitoring equipment for 3D metal manufacturing. We are a public company. We uplifted to NASDAQ last February. We are based in Santa Fe, New Mexico, and we are staffed primarily by technologists with a thin coating of business people like myself.
You know, I was looking at your guys' model. I was looking at some of your 8Ks. Is there a large market for metal parts manufactured with 3D printing?
It's very interesting. Today, the market, a year ago, according to Wohlers, the market was only about $80 to $100 million of metal parts being manufactured with 3D printing. And yet the potential of the market is simply enormous because the technology allows parts and products to be designed and manufactured in one piece to meet all kinds of requirements and specification. It's an extraordinarily disruptive technology that changes our current mass production model for many, many parts and products. So here's a famous example. The GE fuel nozzle reduced what was a 20-part assembly to one piece formed with 3D technology.
Wow.
That cut costs significantly. It cut weight significantly. And indeed, in high tech and in aerospace, there's sort of a common thumbnail test that's come up for should I manufacture with 3D metal. It's 40-40. Does it cut the weight 40%? And does it cut the cost 40%? And in the case of GE, they did that. It also, so it's a technology that in GE's case is being deployed to make as many as 40,000 of these fuel nozzles a year with additive manufacturing. That's a big deal. And that's the first real breakout into the metal space. It has terrific potential for one-off parts like your customized new hip joint and things like that. You imagine companies not having to maintain a large inventory, but rather just have a digital file. Now, a part is needed, the file is downloaded to a 3D service bureau near the customer or to a customer's own 3D machine. The file tells the machine to make the part, provides the specification, the part is made and finished. So the development of the 3D metal market has so far trailed behind plastic. The plastic market is about $10 billion and growing at 20 to 30% a year. Metal is still being used for prototyping, but so far rarely for quantity manufacturing. So where we sit, we know that these are really exciting, compelling designs and necessary improvement. The market's potential is enormous, but it's in the future. It's not today.
I was looking at, like I said, some of your 8Ks. Explain to me your sensor pack. I know it's multi-sensors. Why is that so important?
Well, what we are doing is putting sensors in the manufacturing chamber of an additive manufacturing machine and gathering data with those sensors and feeding that data into our sensor pack. we are gathering data on every single layer of an additive manufacturing parts production, which means that we are gathering a huge amount of data. And we are organizing that data in the sensor pack and then feeding it to a processor, which will tell us, is this a good part or not, in real time in the machine.
It seems like to me, it's a very, you guys are a very high-tech company. Is there a lot of companies that have this sensor pack or multi-sensors, or I'm sure you have a patent on it?
Well, it's very interesting. Yes, we have a broad and wide domain of patents. The space is interesting in that many of the equipment manufacturers, the people who make the machines that make the parts with additive manufacturing, are beginning to put sensors such as we use into their equipment. We are the only people who are using that data to inform operators of the quality in real time of their products. We are not aware of any company yet, large or small, that is doing what we do as well as we do it.
You should be able to find a lot of customers that probably need to use this technology in aerospace, medical. What is the range of your customers?
Most of our customers today are very high-tech research folks. They're people like Honeywell. We've worked with GE. We are working with Siemens. We have worked with most of the large equipment manufacturers as we seek to do OEM deals with them. And because this is a space that large high-tech companies know that they are going to do. They're not wondering if they're going to do it. They're trying to figure out when and how. And so all of them are very active with their own research projects, and we team with them to do that.
My guest today is John Rice. He's the CEO of Sigma Labs. They trade on the NASDAQ, ticker symbol SGLB. John, what role will Sigma Labs play a part in the growth of 3D metal manufacturing?
Well, you had asked earlier the size of the market.
Yes.
And the problem, the question is, why hasn't the market taken off? And the answer is, it has a problem in assuring the quality of parts made with 3D metal manufacturing. 3D metal manufacturing actually uses a laser to sculpt a product, to grow it almost, out of powdered metal. In layer by layers, some of those layers are on average the width of a human hair.
Wow.
So the problem that has emerged is that traditional quality systems for mass manufacturing, where you start with a piece of metal and carve it with a very predictable CNC machine, they just don't apply here. If you make 10 parts with additive manufacturing, there will be some differences among them, but on a 10-part base, there's no quality system today, traditional quality system, that will tell you which one's good. So metal manufacturing today requires that you inspect 100% of the parts closely and carefully. GE is using CAT scans as part of their quality inspection of the fuel nozzles. It costs many people $6 to inspect a part for every dollar they spent to make it. So what's important about Sigma, the role we play in the future of the industry, is we are the converging technology. 3D metal manufacturing is a new technology that, like many new technologies, requires the help of other technologies to be fully usable and deployed. So our technology is in-process quality assurance that addresses the odd differences between 3D metal manufacturing and traditional subtractive metal manufacturing. We can tell in real time whether a part is in specification. We tell the operator, we give them a green, yellow, red indicator. This part is green, no worries. This part is yellow, you will have to inspect it after production. But It is not red. Red is, this part is not good, stop making it. And you can do that in real time. So you stop wasting material, you stop wasting energy,
Right.
you stop wasting time on the bad part. And each time you find a thing like that, you have the opportunity to make some adjustments that may prevent that from happening again. So our importance is that we are taking data in real time, understanding how to convert that and say, this metal is still in specification. This part is true to your design. It will have the tensile strength, the fatigue properties that you must have. And that is technology required for for metal AM technology to take off. It is ultimately a large multi-billion-dollar market in which people make products in quantity like GE's fuel nozzle, or one-off like a replacement part for an old system on an aircraft carrier that's in the ocean, whatever. But in order to reach that point, the industry needs a tool like ours that tells you whether that part, what many or one, is meeting spec now. So think of it this way: if manufacturing high-quality metal parts with 3D technology looks to some people like a lock, then PrintRite 3D is the key.
John, I want to thank you for coming on the show. In closing, is there anything that we didn't get a chance to touch upon that you'd like to get out there to the listeners?
Well, there's always something we miss, but I think that the big idea is this is an exciting technology, and it will be fun as consumers, investors, business people, wherever we sit in society, to watch this improve and change the way we live.
Well, I want to thank you, first of all, for coming on the show. It's a pleasure to have you on here. I wish you nothing but continued success. Hopefully you'll come back on the show in 50 days and give us an update of where you guys are at and what's going on with Sigma Labs.
Well, thank you. We'd love to come back.
This program is entirely sponsored and produced by Uptick Newswire, LLC, which is responsible for the content. The opinions and information provided on this program are those of the guests and those of the respective companies they represent, and do not necessarily reflect those of the staff or management of Uptick Newswire. Uptick Newswire encourages all listeners of this program to do their due diligence and research when determining investment strategies that will work for them, or to seek the assistance of an investment professional. The guests of this program may have paid for its distribution and are not directly affiliated with Uptick Newswire or this station.